at the end of class, someone helped remind me to turn off the recorder. I remember last Thursday, not in this class, but my next class, I forgot to turn it off and didn't realize that until I was loading this 2 classes later and saw I had almost 6 hours of recording. I went, whoops. Okay, so I had to put both of them out there in their YouTube videos and just say, you've got the first hour and 15 minutes. The other class, you have to skip the first hour and 45 minutes, and you pick up from there, and you have the last 2.5 hours, 4.5 hours. So it was a mess. Okay, we are recording now. Let me get my screen sharing started. And we are in 4.2. We hopefully will move along on that today. And I'm going to need to move this toolbar or taskbar, whatever you call it, out of the way because it's smack dab in this part of the screen that I want to read. And we'll go to the slide from current slide. Trying to get current slide to open. There it goes. And I think we had done this maybe last time, but if not, let me do one other thing here. Bennett, of course, is in the way, so I got to scoot him over to the right. Now he's out of the way. And is that somebody else coming in? Yes, Azora is coming in, so let's get her here. All right, good attendance today so far. Keep them coming. Okay, let me just check and see. We're up to 15 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Got it. Okay. Now, again, I'll ask the question. Somebody else. Damien's coming in. Let me get him here if I can. I think I got him before he faded out. Damien's here. Okay. Was that somebody else that popped in while I wasn't looking? Should have 16 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Got it. All right. Again, any questions before we get started where we left off before? None? All right. We were doing the example 1 here. This is on chapter 4 trigonometry, section 4.2 trigonometric functions, the unit circle, and we're doing example 1, and this is the D part was where we left off. We had the first 3 done. We didn't get to do the D part. T is equal to minus pi thirds. Now, if you remember, and hopefully you do, what we were doing before, let me check, I was using, fine. Oops, here comes Jalen. Let me get Jalen in. Okay, hold off a moment here. Let me get Jalen here. Okay. Jalen's here. Did anyone else pop up while I wasn't looking? Should have 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Got him. Okay. Now, again, I'll ask, any questions before we get started today? Okay. Now, we're on the D part here. We have already evaluated the 6 trigonometric functions. By the way, those who just came in, chapter 4, trigonometry, section 4.2, trigonometric functions, the unit circle. Example 1, top of page 272, if you're following in the book. Now, I realized sometime later, not everybody has physical books. If you have an e-book, it probably is the case that you can't have the e-book open at the same time you've got Zoom open. Now maybe you can, I don't know. I probably couldn't, so, but maybe if some of you have split screens and stuff, you could. I don't know what your situation is. Certainly if you're on the phone, that would be hard to do on the phone. It's hard enough to do anything on the phone. So I'll always try to say where these were so you can go back and pick them up later. Here we have t is equal to negative pi thirds. And what I like to do is draw the picture. Now, on this screen, they're going to be really ugly pictures because this is not a very, I don't draw circles well, but let's just imagine that's a circle. Okay, and let's just imagine we got a vertical axis, the y-axis going through it here, and the x-axis going through it there. Now that's not very smooth axes. Let's just imagine that is the center of the circle. Okay, this imagine is the positive x-axis. Now where is negative pi thirds from the positive x-axis? It's going in a clockwise direction, and remember all the way around here would be negative pi, so a third of that would be something about like that. So this angle here, or they like to call it real number here, would be negative pi thirds. That's your negative pi thirds. Now the question you have to ask yourself, what are the oh, is there somebody else? Yes, somebody else has tried to come in and I did not see who they were. So let me see if I can find them. Well, I don't see them. Maybe someone went out. Okay. Should have 17. I don't remember what the last number I counted. 2, 3, 4, 5, 6, 7, 8, 9, 13, 14, 15, 16, 17. Yeah, we got everybody. Okay. That was, I guess, a false alarm. But I'm worried about people, missing people. I think it was someone from this class, or it may have been my afternoon class, said they sat out in the waiting room for about 15 or 20 minutes and never was admitted. And they showed me, they sent me the screen and said, please wait for the host to invite you in. Well, I was allowing people in many times during that 15 or 20 minutes. Their name never showed up, or else they would have come in with everybody else. So I don't know what's going on. Systems are pushed to the max. Zoom is pushed to the max. They had a breakdown a couple of weeks ago, major one. We're on Spectrum. My wife yesterday was in a meeting. She could hardly hear anything because it was getting garbled. She had something on her phone. She could look at the signal strength. We supposedly have a good system that's supposed to be in the 90s or 100, whatever that is, and she was getting like a 3 or a 4, you know, at the time because it was middle of the day and the signals were just terrible. We had good internet. I had 5 bars, she had 5 bars, but she just couldn't get a decent signal. So that happens. So if you see or sense anyone trying to get in, please let me know. Stop me. Let me get them in. This place where they come in, I don't know. Can you see this box, this rectangle up here at the top? It says, please move this window away from the shared application. Can you see that on your? Yeah. And you see it's really dark now. In a while, it'll fade away. But as soon as someone comes in, that's where they pop in. And when I go to see them, it blacks them out. So that's why I have trouble seeing. I have to wait till they fade away so I can read who it is coming in. I can't move this. It says, please move it. I can't move it. I've never figured out a way to move it. I've had students try me different things to try. I can't do it. I mean, it's one of these stupid systems that's supposed to, I don't know what it's supposed to do, but it's the thing that we're running Zoom, I'm running PowerPoint, I'm running Screencast-O-Matic, I'm doing all this stuff at the same time, writing with my Wacom on the board. I mean, I have all these things active, and they just interfere with each other, and I can't do a thing about them. All right, so anyway, let's get back to where we were. Do you remember anything special about this? What we want to know is the XY coordinates of this point down here represented by t equal negative pi thirds. Well, now my drawing is lousy, but if you can imagine this, let's go to the x-axis. And remember, this is the unit circle. So this is 1, that's 1, this is 1, this is actually a -1 here, this is a -1 here. All these are 1 unit away from the center. So if this is 1, 0 out here, which it is, then right about where that sure looks like that could be 1/2, doesn't it? So let's just say, and yeah, pi thirds, that seems like that would be that. So this would be 1/2 is the x coordinate. Does anyone remember what that would make the y coordinate to be? Obviously it's negative here. Negative. Anyone remember? The square root of 3. If this pen would write, these stupid things get popping up here. -3 over 2. There's your y coordinate. I didn't put my parentheses too good, but that's what we got. There's our point. As soon as we get that coordinates, we got it knocked. We can do the sine of t, sine of negative pi thirds. We can do the cosine of negative pi thirds. We can do the tangent of negative pi thirds. We can do the cotangent of negative pi thirds. We can do the secant of negative pi thirds. And we can do the cosecant of negative pi thirds. Now you might prefer it if I put them in parentheses. I'm having trouble writing periods, so I have it. But yeah, they are probably easier to read if you do it that way. Okay. Now, does anyone remember what the sine is? The sine is always, on the unit circle, it's the y coordinate. I always say that, on the unit circle. So this is simply negative square root of 3 over 2. Anyone remember what the cosine is? The x coordinate, you got it, 1/2. That's why it's important to figure out what your coordinate points are there. The tangent, you remember what that is? Sine, yeah, sine over y over x, you got it right. This one over that one. And when you do that, the 2's will cancel, divide out, multiply both numerator and denominator by 2, and you have merely minus root 3. Now, remember what cotangent is? Yes, x over y. So it's the reciprocal of tangent. It would be 1 over, or negative 1 over root 3, which a lot of time, I'll write it that way, negative 1 over root 3, because the 2's cancel out. But if you want to rationalize that denominator, it's negative root 3 over 3. Okay? Secant. Remember what? Yes, you're absolutely, yeah, 1 over x, you're actually, and your x is 1/2, so that would be 2. Perfect. Okay? It's reciprocal of cosine. To me, that's easier to remember 1 over x. It's just, you got this written down, write its reciprocal. How about cosecant? What would that be? Wait, yeah. Azora raised her hand. What you got, Azora? Okay. Okay, we're in week 3 right now, if that's what you're asking. Yeah. Next week will be week 4. Okay? Yeah. Hey, and if you're worried about something they've got in Blackboard, Don't worry about Blackboard. It's a mess. They put these shells out there. They put things in. I have absolutely no idea how they did it, why they did it, or something else. They're there. When I can get in, I was telling my last class this, I think. Um, I finally got taken care of most of the administrative stuff. I'm sure they'll come up with more, but most of that, and I'm now in the process of trying to print things that have been turned in the last couple of weeks. Here's what I've printed so far, okay? I've got this much stuff I haven't graded yet or marked yet. Some of it won't have a grade. It'll just be acknowledging its receipt. As soon as I can get through that stack, I will start putting those notations in Blackboard. So don't sweat if Blackboard is telling you you got a 0 for week 2 or something like that. Don't sweat it. That's Blackboard. That's not me, okay? When you see mine there, basically here's what. All these things that are, and I'll try to put headers on them, okay? I don't know if they're there, like syllabus acknowledgement, research paper topic, week 1 home or week 2 homework, week 3 homework. I'll try to put those topics. What they have there is just stupid, okay? I'll put down those topics. They will, if you've turned something in and I've received it and acknowledged it, then it'll have a 0 points. There's no points, but it'll be posted. If you have a posted there, that means I got it. Now, if you don't have a posted, that means I may have it. I just haven't posted it yet because I haven't gotten to it, okay? So don't be sweating anything that Blackboard's telling you there. Now, I can't remember in this class if someone's turned in a research paper yet. I have one class, 2 people have turned it in, another class, 1 person turned it in. Those classes will have a research paper score there. That will be based out of 100. And when you have your first test, that will be a score based out of 100. All this other stuff is zeros, but it's either posted or not posted, okay? There won't be a 0 there if it's not posted. It says, on mine, it says grade now. So if there's something there and says you have a 0 out of 100, ignore that. I didn't put the 100 in there. I didn't put a deadline in there. Blackboard did it. Whoever set up the shell did some sort of silly something or another. So don't sweat those things. I'm sorry, that's probably way more than you were asking. But yeah, we're in week 3 now. Next week will be week 4. So basically, week 1 assignment was syllabus acknowledgement, research paper topic. But you can turn that research paper topic in anytime. But I'll put that under week 1. It'll go where week 1 would have been. Week 2 will be just a homework. At least 1 homework exercise from week 2. At least 1 from week 3. And there was a student in my last class who said she hadn't been able to do anything this week because her kids started school and she's working on 3 different computers at the time, trying to do virtual learning for all 3 of them. And she said, I haven't had a chance to turn in any homework. Can I do it over the weekend? Sure. If Blackboard says you're past due, ignore them. Turn it in. If you didn't get something turned in for week 2, turn it in. If you didn't turn in your research paper topic, turn it in. I'll go back and fill in the blanks, okay? So don't sweat what Blackboard's telling you. I'm the one that gives the grade, not Blackboard. So I'll take care of that when I can. Now, I told my last class this too. Right now, I'm still in the printing phase. This is only part of what I've got out there. There's more stuff I haven't gotten to yet. If you haven't received an acknowledgement from me, that means I just haven't printed yours yet. This evening, I'm going to try to print as many as I can. Tomorrow morning, unless they come up with something stupid as for us to do tomorrow, I hope to be able to print for about 4 hours, okay? I know that won't happen, but I'm hoping. So, anyway, I hope to get as much printed as possible before the weekend, and then the Labor Day weekend, we're going to be out of town. My wife's parents, they're both in their mid-80s, and they just this week celebrated their 65th wedding anniversary. So they wanted to get out of their house. They've been confined to their house for weeks and weeks on end. So we're going to meet them up at Smith Lake They had a place up there that we take care of now, and so I've got to go up there and mow and sweep and rake, and my wife's up there right now, or she's on her way up there now. She's going to be spraying and things, so we're going to try to get things ready for them, and they're going to come enjoy the weekend with us, hopefully. And but I hope during my spare time in between all that, I'll be able to get some of this caught up. The bad news is their internet service up there is terrible, okay, because it's way out in the sticks, isolated from so many things, so there's no good signal there. And I know all of them are going to be trying to work on their cell phones and things. My wife is probably going to be trying to do some of her work. I probably won't be able to. We don't have a printer there, so I won't be able to print anything there, but I will be able to mark in my grade book, which I finally got updated last night. I'll try to put those things in the grade book, and then if I can, I'll try to put them on Blackboard, but the odds are I won't be able to do that until we get home on Monday. I don't know what time we're getting back, but I'll try to get that done. That leads me to the other thing. I should have said this early on. You know the good news, bad news situation, don't you? The bad news is next Monday is a holiday, Labor Day. The school's closed. As I just said, I'm not going to be here at least Monday morning. I won't be available. I won't be able to, I may be able to read an email, possibly answer it. I don't know that for sure, but I sure won't be able to print anything or anything like that. Going to be out of town, okay? That's the bad news. School's closed. No classes on Monday. The good news is, doesn't bother us any because we meet Tuesdays and Thursdays, so we won't miss a class next week. So I know that makes you happier now. So let's move on. Now, I can't even remember your question. I know, Azora, you said the thing about the weak stuff. This was the problem. I thought someone else was asking this. This was the problem we started last week. We did on Tuesday, this week. We did A, B, and C. We're doing D now, and we're almost through with it. What would be the cosec of negative pi thirds? What would that be? 1 over y, and your y was minus square root of 3, square root of 3 over 2, so this would be 1 over that, would be minus 2 over root 3. But a lot of times they don't like to write radicals in the denominator, so if you multiply the numerator and the denominator by root 3, you get minus 2 root 3 over 3. And that's how they like to write it. So there's the D part. Any questions on that? Yes.
So if we need like further explanation, we'll look back. All this will be in the book too, right?
Yes, this is in the book. Yeah. And it's also, I'm recording it now, so it'll be out there on a YouTube video late today, sometime late this evening. Yeah, but it's there. And in the book, it's on page 272. And this shows what the book does. Okay, now I can't erase the screen. Sorry about that. I hesitate to write on it, but this is sort of background stuff. So here's what they do. So each t-value, begin by finding the corresponding point xy on the unit circle. That's what we did right here, is find that the point. Figure out where negative pi thirds is, where that intersects, find the coordinates for that point. Once you do that, you've got it. Use the definitions. So for the first one there, pi 6, that was up here somewhere, and there the x coordinate was the root 3 over 2, and the y coordinate was 1/2. Okay, both of them positive because that's in the first quadrant. Okay, so there was root 3 over 2, 1/2. Once you got that done, you've got all 6. The sign is the y, which is root 3 over 2, 1/2, the y value 1/2. The cosine of pi 6 was the x value, which is root 3 over 2. The tangent is the ratio of those, and that's 1 over root 3, which is 1/2 over root 3 over 2. And in this case, the over 2's can divide away, multiply away actually, leaving you 1 over root 3. which you can write as root 3 over 3. Then the cotangent function, they go to cosecant, it's the reciprocal of sine, so that would be 1 over 1/2, which is 2. I just find it easier to reciprocate this rather than write it like that. But you can write it like that, it's perfectly fine. The secant is going to be reciprocal of this, 1 over x, so that's going to be 2 over root 3. Just reciprocate that, which, by the way, if you rationalize the denominator, is 2 root 3 over 3. And then the cotangent function is y, or x over y, and that was your root 3 over 2 over 1 over 2. And again, the over 2's go away, and that just gives you root 3. Done. That was the A part. Here's the B part. Where in the world are you, Waldo, when you're at t is equal to 5/4 pi? 1/4 pi would be your 45 there. 2/4 pi is your 90. 3/4 pi is the 45 in that direction. 4/4 pi, or pi, would be that way. 5/4 pi will be down there. Third quadrant, splitting the middle, going down. There the coordinates would be minus root 2 over 2, minus root 2 over 2. Third quadrant, okay? So the sine of that is going to be the y value, minus root 2 over 2. The cosine is going to be the x value, which is also minus root 2 over 2. The tangent is the ratio of those two, and since those two are exactly the same values, the ratio is minus root 2 over 2 over root 2 over 2, minus root 2 over 2. Everything goes out. These go out to be 1, these go out to be 1, these go out to be plus 1. Okay, so your answer is 1. Okay. I think they do the cosecant next, which is 1 over this. Now, I'm going to do something a little strange here. I'm going to write this not as root 2 over 2, negative root 2 over 2, but I'm going to unrationalize the denominator and write that as minus 1 over root 2. That's how you got this in the first place. So if you then reciprocate this, that would then be minus root 2. And you can do that in one step. Whereas here, they're going to write it as minus 2 over root 2, and then write that as minus root 2. So the answer is minus root 2, however you get there. Which will be the same for secant, because cosine was the same as sine. Cosecant is 1 over x, and that's going to be same deal, minus 2 over root 2, which is minus root 2. And then finally, your cotangent is going to be your x over y, but remember, y over x was 1, x over y is also the same deal, and that's 1. Okay, so there was the B part. The C part, we did these last time on Tuesday. The C part, t equal pi corresponds to the point over there at minus 1, 0. Pi away, on the opposite side of where you started, negative 1, 0. So guess what? Your y value, sine of pi is your y, which is 0. Cosine of pi is x, which is minus 1. The tangent of pi is y over x, which is 0 over a minus 1, which is merely 0. Your cosecant, you run into problems because it's 1 over 0. Can't do that, undefined. You do not have a cosecant at pi. Just won't happen. Later, we're going to be graphing these things. You'll have a vertical asymptote there. Okay. However, you can do the secant 1 over x, because x was a minus 1. This is 1 over a minus 1, which is minus 1. Your cotangent, again, is undefined because that y, which is a 0, is in your denominator. You can never divide by 0, so therefore it's undefined. So that's the last one we did Tuesday. Here's the one we did today. This time, we're going minus pi thirds. So that means you move clockwise around the unit circle, and you go a third of the way from horizontal this way to horizontal that way, but going clockwise, that would be down here in the fourth quadrant. And that point corresponds to 1/2 on x, negative 3 root 3 over 2 for y. Once you have those, you can write down the sign. The sign of that would be your y value, which is negative root 3 over 2. Your cosine is your x value, which is 1/2. Your tangent is a ratio of those, which is minus root 3, because these denominators here multiply away, and that gives you minus root 3. Your cosecant is going to be reciprocal of this one, which will be a minus 2 over root 3, which is minus 2 root 3 over 3. So 1 over y, which is minus 2 over root 3, which is minus 2 root 3 over 3. And by the way, in my mind, either answer is perfectly fine. So if you want to rationalize the denominator, you can. If you don't have to. Now, excuse me, the bad news here, I don't know if any of you know and love WebAssign. I always have at least 1 or 2 students every term that say, are you going to do WebAssign? And I say, do you want to do WebAssign? They say, yeah, we like it. So I have the people at Cengage put sample problems out there on WebAssign so you can do them to your heart's content. However, if in WebAssign they programmed it to read that answer and you gave that answer, it'll mark it wrong. It'll say you're wrong. You're not wrong. You're absolutely right. You just don't have it in the form they wanted you to have. Some other places, they may want you to be in this form. If you put it in this form, they'll say you're wrong. Both of them are correct answers, and that's one reason I typically don't use WebAssign, because it turns out the times I have tried to use it in the past, I spend more time calming students down, telling them, no, you did do it right. Every step was right. You just didn't get it in the form they were looking for. It's not a wrong answer, even though WebAssign says it is. It's just not the answer they were looking for. You did it right. If that were a test, you get credit for it. Okay? If I'm grading the test, which I grade my own tests. That's why I don't have WebAssign grading them, because I have to go back and regrade them anyway to make sure they didn't mark something wrong that was right. So it just, to me, is a pain in the neck or some other body part. Excuse me just a second. I've been talking since 8:30 and my throat's getting raw. Okay, so there's cosecant. And secant is 1 over x. And remember, x was 1/2. So this will be 2. 1 over 1/2, which is simply 2. And then the cotangent, which was the x over y, which would be 1/2 over root 3 over 2, negative root 3 over 2, which would be, again, the negative, the 2's in the denominators would multiply away. If I can get my pen to show up somewhere here. There it is. These will go away, and that'd be negative 1 over root 3, which you can rationalize to be negative root 3 over 3. Done. Any questions? And by the way, Kelly, those are all in the book just like that, almost identical steps and everything. So you can see them there, see them anywhere. All right, Shirley. Now, after every one of these examples in the book, there is a checkpoint, which are slightly different problems, but exactly the same, covering the same material, and there are even 4 of them there. Audio video solutions for those are found at larsonprecalculus.com, the absolutely free website, one of the 3 that this author provides. That's why I like this author. The way he presents material, no different from anybody else. The websites he provides, that is different. Okay. Any questions? All right. Now, moving to the next page, 273, domain and period of sine and cosine. Later we'll do the same thing for the other functions, but sine and cosines are the ones we use the most. Tangent we use a lot. Was that somebody coming in? I don't see that it was, so I don't know what the noise was about. You may not have even heard the noise. It binged in my ear though. Okay, but sines, cosines, and tangents are the trig functions we use the most. Let's just focus on sines and cosines. Now, the domain of the sine and the cosine is a set of all real numbers. Sines and cosines are defined everywhere on the real number line, set of all real numbers. Now, from pre-calculus algebra, you may be used to thinking of the x's to being the domains and y's the ranges. And when you're drawing a unit circle, that's not the case. The sine and cosine are the points along here. The sine are the y values along here, and the cosines are the x values along here. So this isn't a plot of these. So if you think about that though, think about what this sine is doing. Sine starts here at 0, that's the y value here is 0. It increases because your y is going up, it increases going up until it reaches 1, right? But then the y starts decreasing again. It never exceeds 1. It gets to 1, but never exceeds it. Then it starts decreasing again till it goes back to 0, keeps decreasing until and goes negative here. So the y value, the sine, is negative here until it gets to -1, and that is as low as it will go because the y value starts increasing now, still negative, but increasing until it goes back to 0. So your y values, which is your sine function, the output, the range of the sine is from -1 to 1, including the endpoints. Okay. The domain of sine, all real numbers. The range of sine, always between plus or minus 1. Do the same thing for cosine. Cosine is the x value. It starts here at 1, starts decreasing in x. The x is moving this way, decreasing but still positive, but decreasing, going to 0 when you get here. And it keeps decreasing, just going negative here until it gets to -1, and it stops decreasing and starts increasing again. The x value does, and it's still negative, increases till it gets back to 0, and then here it keeps increasing, now going positive until it gets to 1, stops increasing, and starts its around again. So the range of your cosine is also -1 to 1 because the x's goes from -1 to 1. Remember, with your trig functions, the independent variable is not x, not y, it's t. Uh-oh. I think someone just came in. I can't see who it was or is trying to get in. Let's see if I can find it. Oh, Courtney's coming in. Good deal. Let me get Courtney here. Okay, Courtney's here. Guess what, folks? Okay. Now, we haven't seen Jeremiah Bodie from the very beginning. Do any of you know who Jeremiah Bodie is? Anyone? He turned in a syllabus agreement virtually. He didn't show up in class. He didn't send it to me. He turned it in virtually and got marked present for the first week because he did that. Okay? I didn't do it. Blackboard did it. Okay? And then there's another student named Tiana Johnson. Do any of you know Tiana or Tiana Johnson? She did the same thing. She acknowledged the syllabus sometime that first week, but we'd never seen her. So therefore, according to the rules for our new way of doing things here, if you turn something in, you get counted present the first week. If you get counted the first week, you get that you entered the course, even though you never came to a single class. So those people, if they're on financial aid is paying the school that they're in class, but they haven't been here. Now, if they turn around and say, but I never attended class, so I won't that taken off my financial aid. I don't want an F or an incomplete or anything else. They'll say, no, but you turned something in. To me, that comes close to being unethical, okay? I hate that we are using that kind of thing. But you see, what they're trying to do is get as many students in and not kick people out. But at the same time, by doing that, you count people here who really aren't here. So one way or another, you have problems. But what I'm getting at, those two people are the only two people we're missing right now, meaning of the people who have been here, we've got 100% attendance today. Way to go, team. Way to go. Love to see it. Would love to see it every day. I don't know if either one of those students is ever going to show up, and then the school's got to worry with whether they, just because they did something in Blackboard, that counted them present. They say it does. I say I think that's not being fair to the student. But who listens to me? Okay, so that was my little soapbox. Any questions? So you see what we mean by the domain of the sine and cosine function. All real numbers. The range, though, of sine and cosine is plus or minus, from -1 to +1, -1 to +1. That's all. They just repeat themselves. And because they repeat themselves, they're called periodic functions. And the period is the part of the domain that it covers before it starts back again. And if you think about this, as I just described, sine starts at 0, increasing, decreasing, increasing, and at this point starts again. Well, where did you go? You went 0 to 2 pi. That's the period for sine. Same thing for cosine. Cosine started off at 1, decrease, negative, decrease, turn around, started going positive, or was increasing, even though it was negative, till it reached here, and now it's increasing positive, and then starts over again. Its period is 2 pi. 2 pi. And that's what we're going to hit next. By definition, well, not quite. By definition, the sine of t is y, the cosine of t is x, because xy on the unit circle, the x always stays, the y always stays between plus and minus 1. The x stays between plus and minus 1. It can be plus 1 and minus 1. Both of them can be, but it can't go any further. Okay? So the values of sine and cosine also range between plus or minus 1. So since minus 1 is less than or equal to y is less than or equal to plus 1, minus 1 is less than or equal to x is less than or equal to plus 1. Therefore, the y is the sine t, so sine t is minus 1 less than or equal to sine t less than or equal to 1. Minus 1 is less than or equal to cosine t, which is less than or equal to 1. That defines the range of your sine and cosine functions always. If that's all you got, just sine t and cosine t always stay between plus or minus 1. Always. Now, again, because adding 2 pi to any value t on that first circle, 0 to 2 pi, results in one revolution around the unit circle, you wind up right where you were before. They just show up for any point. For these particular ones, pi fourths, pi halves, 3/4 pi, 5 pi fourths, 3 halves pi, 7/4 pi, and 0. Add 2 pi to it, and you're right back at the same place. But any point, right here, whatever point that is, add 2 pi to it, you're back here at that same point. So guess what? The period of sine and cosine is 2 pi. Every time you go another 2 pi around for t, you're back at the same place you started before. Okay? So that is defining what we call the period. The values of sine of t plus 2 pi and cosine of t plus 2 pi correspond to the same values as sine of t and cosine of t. Similar results can be obtained by repeated revolution, positive or negative on the unit circle. That could be a minus 2 pi and a minus 2 pi. It could be a plus 4 pi, plus 4 pi, minus 4 pi, minus 4 pi, plus 6 pi. Any multiple of 2 pi. So here's how we say that. Sine of t plus 2 pi n, where n is any integer. 0, 1, 2, 3, negative 1, negative 2, negative 3. Multiply that by 2 pi, add it to your t, you're right back at the same value for sine. Let's do the same thing with cosine, 2 pi. So for any integer n, positive or negative, and any real number t, functions that behave in such a repetitive or cyclic manner are called periodic functions. Okay? Now, this is the one place where the unit circle, cycle, cyclic, that means circular. Okay? So, yeah, that's why they call them circular functions. To me, they're angular functions, but they refer to them as circular functions as well. They're periodic because they go round and round and round, repeating themselves every time around. Okay? So here's your definition of periodic function. A function f, any function f, is periodic, not just your trig functions. Any function f is periodic when there exists some positive real number c such that f of t plus c is always equal to f of t. Okay? For every t in the domain of f. No matter where you are, if you add c to that t, calculate it, you'll wind up the same value as you did f of t. The smallest c for which that's true, for which f is periodic, is called the period of f. And for sine and cosine, that was 2 pi. 2 pi. We know that a function is even, now this is a new thing here, even when f of negative t is the same as f of t. It's odd when f of minus t is minus f of t. Now, back when you first ran into this in pre-calculus algebra, you either had even functions or you had odd functions, but the biggest class of functions was neither even nor odd. However, with your trig functions, they're just about always either even or odd. In fact, there's only two even functions, cosine and secant. And guess what? They're reciprocals of each other, because cosine of minus t is the same as cosine of t. Secant of minus t is the same as secant of t, because the value, if you think of it, if you go this way on the x-axis, and say you have an x value here, and remember the cosine is the x, and you go the same direction on negative x. If you go x, you're here, negative x, okay, I'm doing it wrong. So here's your thing. A positive x would be here, minus x here, minus t. Positive t here, minus t here, your x value is exactly the same. That's an even function. Secant is 1 over x. So, 1 over x, yeah. So if you go up here, 1 over x is that value, 1 over that, 1 over x, same value down here. That's an even function. Now, the other 4 trig functions are all odd. Sine, cosecant, tangent, and cotangent. They're all odd. Because sine, if you go up here, the y value is here. If you go down here, the y is the opposite of that. Same value, but opposite sign, because up here, y is positive, down here, y is negative. So going in the opposite direction, counterclockwise or clockwise, gives you the opposite sign. And cosecant is exactly reciprocal of that. Tangent is y over x. The x keeps the same, but the y changes, so therefore tangent changes as well. So sine, cosecant, tangent, and cotangent, are all odd functions. Secant and cosecant are both even functions, the only two even trig functions. See, with trig functions, you don't have a neither most of the time. Okay, if you have it translated or something like that, yeah, that could become a neither. Okay, so here we have, I hope, I don't think anyone else came in, did they? No, we're still at 18. All right, now they give you the answer here, and I wish they didn't, okay? What is, all right, the question here, example 2, and again, they work everything out for you. What I wish they would have said was, what is the sine of pi 13 pi 6? Okay, well, 13 pi 6, let's wait a minute here. I'm going to try to draw my ugly circle again. Okay, I'll try to draw a ooh, that's not a vertical line, is it? Ooh, that's awful. Vertical line, a horizontal line. That should be over here somewhere. Okay, so what is 1/6 of pi is here, 2/6 of pi would be here, 3/6 of pi is pi halves, 4/6 is here, 5/6 is, ew, that's not good, 6/6 is here, that's pi, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6 is 2 pi, that's showing up badly, 13/6 pi is right there. Well, that was the same as 1/6 pi, okay? Because 13/6 pi, and actually if you did the math on that, if you do 6 divided into 13 pi, 6 will go into 13 twice, 2 times 6 would be 12. That would give you 1 pi left over, okay? So that'd be, wait, I'm sorry. Bring the pi up here, and then you have it here, and then you just have a 1 pi left over. I had it right there. And then your fraction would be plus pi over 6. So 6 will go into 13 too, 6 will go into pi. You really don't. You just bring the pi up there with it, okay? And multiply, you get 12 pi, subtract, you get 1 pi. Put that over here, you get 1/6. So that's how they got this. 13/6 pi is 2 pi plus pi 6. Because sine is periodic about 2 pi, the sine of 2 pi plus 6 is exactly the same. Oh yeah, Sharika, you got your hand up. What you got?
Yes, Mr. Fowler. I'm going to have to leave out at 11.
Okay.
Because I have another Zoom meeting with my children's teacher.
I see. Okay, that happened in my last class too. So understand, life gets in the way. I am recording. Now, it probably won't be out there on YouTube until late tonight or sometime tomorrow, okay? But it will be there, so if you want to catch up anything you missed, it'll be at the bottom of the YouTube listing, because all the things will be there. The oldest ones are on top, the newest ones on the bottom. So that's where you'll find it. Okay. Thanks for telling. By the way, you don't have to raise your hand. You can. That's perfectly fine. If you want to just pop in and say, I've got to go, that's fine too. I'm not offended, okay? I talk all the time, so my wife used to say, hey, I got to say something. Yeah, so don't worry. Get it out there. So what this is saying, though, is because sine is periodic about pi, this is exactly the same as sine of pi 6. And we know what the sine of pi 6 is, don't we? The y value when you're at pi 6, if I had drawn this anywhere decently, which I didn't, I can't even find my pen now. There it is, okay. This would have come over here right around 1/2. Oops. 1/2. That's the sine of pi 6. Okay, let's see how they do it. They say that is the same as sine of pi 6, and they say sine of pi 6 is 1/2. Exactly like I said. Okay, they just said it a lot quicker than I did. Okay, now the B part here, what is minus 7 pi over 2? Well, if you want to do it the long way around, here we start here and goes minus 1/2 pi minus 1 pi, minus 3/2 pi minus 2 pi, minus 5/2 pi minus 3 pi, minus 7/2 pi. There we are, right there. Minus 7/2 pi. Or the other way you could have done this was this. Do 2 into minus 7 pi. Well, 2 will go into minus 7 pi minus 3 pi, and that would be minus 6 pi. And then subtract that, and you get a, change that to a plus and add, minus pi. So that would be minus pi halves. Well, that's sort of awkward. Let's add another this isn't working out as well, is it? Okay. If you add another pi, okay, it doesn't seem right. If you subtract another pi here, that would be minus 4 pi. But subtract, you can't just do that. You'd have to add another pi here. Well, another pi here would be 2/2 pi. That's 1 pi. So this would be minus 4 pi plus, because if you do plus 2/2 pi plus minus 1/2 pi plus pi halves, because you wanted to get an even number of pi's. Okay, we lost somebody, I guess. Oh, that was probably Sharika. I had to go. So that means, because that's true, that means, oh, here's Kelly. She must have had to pop out for a moment. Now I can't get my cursor to show up. Where in the world is my cursor? There it is. Let's get Kelly back in here. I think we're back to the same, well, we lost Sharika, but we got Kelly back. Okay. So what we have here, because that's true, and this is an even number of pi's, even though it's negative, this is the same as cosine of pi halves, and cosine of pi halves is, anyone know? Zero. Okay, because if you think about it, pi halves, that's what I said, this is where we were. What's the x value when you're up here? 0. Okay, so that's all you had to answer. If you had counted around like we did and wound up here, then look at the x value there, it's 0. But they're showing you can do it this way as well. Okay. To me, the way they do it is awkward. I would just count around until I found out where we were. Okay. And that's cosine of pi halves, and cosine of pi halves is 0. Okay, is there a C part? There is. Ha! This time, sine of t is 4/5. Now, time out a moment here. Whenever they say something like this, I say, wait a minute, does that make sense? Okay? Well, guess what? Sine of t is always between plus and minus 1, because y is always between plus or minus 1. Is 4/5 between plus or minus 1? Yes, it is, so that makes sense. If they had said for sine t equal 5/4, hang it up. Not going to happen. Sine of t will never be greater than 1 or less than negative 1. It's always got to be between plus or minus 1. So this makes sense. Now they're saying, so therefore sine of minus t would have to be minus 4/5 pi. 4/5, no pi in there, minus 4/5, because sine is an odd function and sine of minus t is the opposite of sine of t. Okay? Because sine is odd. Now, I wanted to show you this, but we haven't graphed the functions yet. But I'll do something from pre-calculus algebra. If we think of, where is my pen? There it is. Okay. If we had All right, I think we lost somebody else. Okay, someone else had to go. Okay, if we had a quadratic here, I tried to make it symmetric about the y-axis. If this is your x here, here's your y value. If this is minus x, it's the same y value. That is an even function. And that's what we mean by an even function. It reflects across the y-axis. Now, if you had, that's a quadratic. If you had a cubic function that did like this, and then did like this, mine didn't quite go properly, but it should have gone through the origin. If you go the x value here, you're right here. If you go the y value there, you're down here. Exactly the opposite. This is positive, that's negative, but by the same amount. Now my figure doesn't look like it. That's what we mean by an odd function. So guess what? When we get around to graphing the sine function, we'll see the sine function looks like this. Yuck, that's not very vertical. I don't draw well, sorry about this. Sine function does something like this. So you see, if you go over a certain distance here, you go up here, go in the opposite direction at the same distance, you're in the opposite thing. Whereas the cosine function looks like this. Again, I don't draw. Cosine function is like this. Okay, if you go to the right so far or the left so far, you get the same value for your cosine. It's an even function. Even functions reflect across the y-axis. Odd functions reflect across the origin. You go the opposite here as you do there. Okay, here and there. Even functions reflect across the y-axis. Okay, let's see if there's anything else to see. No. So that finished example 2. Now I'm trying to see where we're at. And by the way, for every example, there's a checkpoint. Please do the checkpoints as soon as you can after class. Their answers are in the back of the book. If you can't get those answers, audio video solutions for both English and Spanish are at larsonprecalculus.com, which is an absolutely free website. Anyone can go there. You don't need a code. You don't need a class key. You don't need anything. Just go there. Okay, excuse me just a second. Okay. Now, yes. Okay, it's actually the very next page to where we are right now on page 275, and there'll be the odd numbers in every group of those that you see there. So if you listen in on the recording, what we do at the end of class or at the end of the section, I'll go over every one of those. So yeah, it's on the next page of 275 and 276. All right, good deal. All right. When evaluating trig functions with a calculator, you can do that. It's only those favorite functions that we know exactly what their values are. The rest of them, we're basically going to have to use a calculator. You need to set the calculator in the desired mode of measurement, degree or radian. Now I use my phone for a calculator, okay? So I log into my phone, okay? Go to the utilities thing, I don't know where you do, and then one of those utilities is a calculator. And when you have it in this mode, you can't do a trig function. If you turn it sideways though, you do get your trig functions over here. But up here near the top, you'll see a thing that says radian or degree. Mine is in radian mode right there. I don't know if you can see it. You see the RAD? It's in radian mode. So whatever I'd put in there would be that. If I want to change that, there is a key down at the bottom here that says DEG. So, okay, somebody just came back. Courtney just came back. So let me admit Courtney back in. So if I press, somebody else come in. I don't see anybody else. Okay, if I press the DEG here, notice the radian disappeared. So that means we're in degree mode. Now that's how, well, no. Down here at the bottom it says RAD, but it doesn't say up here. Now I had thought it was backwards because I saw that. No, it only says radian when you're in radian mode. If you don't see anything at the top, it's degree mode. Now I have a iPhone. It's my wife's old one, so this is the old version. I don't know if the newer ones are the same way or not, and I don't know about Androids or others. But if you want to get to radian mode, hit the RAD key, and then you'll see you're in radian mode. To get back to degree, you hit the DEG key. It's the same key that I hit. So this puts us in radian. Always, always, always check that first. Now, most calculators do not have keys for cosecant, secant, and cotangent. They do have, if you notice here, there's your sine, your cosine, and your tangent. These things down here, don't worry about that. That's a hyperbolic sine, hyperbolic cosine, hyperbolic tangent. We are not dealing with those. They have nothing to do with secants, cosecants, and tangents, so don't worry with those. But most calculators only have the keys for sine, cosine, and tangent. They do not have the others. To evaluate those functions, you use the x to the -1 key, also called the reciprocal key. And on this calculator, I think that's it right there. I can't read. No, here it is. It's the 1/x key. So it's either going to be a 1/x key or it's going to be the x to the -1 key. One of the others of those. Okay? And just remember which are the reciprocals. That's why I always refer to them. They say 1/y and 1/x or y/x or x/y. You know, they refer to them that way. Now they turn around and call them reciprocals. I like to call them reciprocal functions from the very beginning so you remember that. Okay. Now, I can't get it to advance. All right. For example, to evaluate the cosecant of pi/8. Okay. Now, different calculators have different algorithms. Okay. If you actually have a scientific calculator or a graphing calculator, then all you do, you don't have a cosecant key, I don't think, but you know that cosecant of pi/8 is 1 over the sine of pi/8. So what you could do is do sine, and when you do sine, it opens up a parenthesis for you. Then you do pi divided by 8, close the parentheses, press equal. That will give you your, oh no. Sine of pi/8, then press the reciprocal key, and that will give you the answer. You don't usually even have to do an enter. Okay? Now, on this, my phone, it doesn't operate that way. It has a different algorithm. What you have to do on it is do the pi/8s first, and once you get the pi/8s in there, then you press the sine key. And once you get the sine of pi/8s, then you press the reciprocal key, and that gives you your answer. So I'll show you how to do that on mine, but remember, your calculator, your phone may have a different algorithm. You need to know your own calculator. Okay, now let me give you a hint. They haven't talked about it in the book yet, but it's true. Because sine and cosine always stay between -1 and 1, right? Secant and cosecant are always outside -1 and 1. A secant or a cosecant will never have an answer of 0.5 or a -0.3 or anything like that. It's always going to be something 1 or greater, -1 or less. Sine or cosine are in between -1 and 1. Secant and cosecant are outside of -1 and 1. So if you get an answer for a cosecant that's in between -1 and 1, you got the wrong answer, okay? You probably have the sine or cosine. So I'll show you how to do this on my calculator. I've got to turn it over. I have to start with the pi key, and that's the one, I think it's right down here. There's the pi key. It's really hard to see. There's the pi key right there. So I'll do pi divided by 8. And I have to do equal then. You could have done it in parentheses if you wanted to, but it's easier to just do equal. That gives me this number here. Now, since I'm doing pi over 8, okay, there's no degree sign. I'd better be in radian mode, and sure enough, I am. That should have been the first thing I looked at. Okay? I forgot to mention that, but it needed to be. So there you have pi over 8. So now I press the sine key. Okay? There's the sine key right there. So I'll press the sine key. Now, if you noticed what that was before, it was a 0.38 something, and the sine is also a 0.38, so different number. But for small angles, sine and the angle and the sine in radian mode are very close to each other. That's one way you can tell if you're in the right mode. But that gives you sine. That answer right there is between -1 and 1. To get the cosecant, I have to do the reciprocal key, and in my calculator, my phone, it's 1 over x, this key right there. So I'll press that one, and that gives me a 2.61. That makes sense for cosecant because it's greater than 1. Okay, so my answer is 2.61259297, more digits than they give here. Same answer. Okay, there it is. Same answer as you see down here. Okay, do you see how to do that? You don't have a cosecant key, so you use that reciprocal relationship. Okay, now I don't think we're going to have time because we just went over. Yeah, so we will do the example 3 next time. I bet you y'all can do that by yourselves. I bet you can do that. But if you want to go over it next time, we will. We will start there and move on from there. So let me give you your homework assignments. God, can't get my phone to plug in. Okay, that time it did. Okay, so next time we'll be beginning with example 3. Okay, let me erase the mark from before. Okay, and all right, homework assignments on the very next page, starting on page 275. Either 7 or 5 or 7, they're both at Calc Chat. Either 9 or 11, they're both at Calc Chat. Any of the odds 13 to 21, they're all at Calc Chat. Any of the odds 23 to 29, they're all at Calc Chat. 23 is at Calc View. Any of the odds 31 to 35, they're all at Calc Chat. 31's at Calc View. Any of the odds 33 to 41, they're all at Calc Chat. 37 to 41, they're all at Calc Chat. 37's at Calc View. Any of the odds 43 to 47, they're all at Calc Chat. And we haven't really talked too much about harmonic motion, but try to do number 49. Okay. Let me back off a minute here. No. Stop at 41. We'll wait and do 43 to 47 after we do that last example. Okay? And that will do it. Now, next time, we'll finish that last example. It's on the slide set, so I'll bring this up, and then we'll get into right triangle trig 4.3. Okay? Hopefully next week we'll get into 4.4 as well, and after we finish 4.4 will be your first test. So anticipate that to come no sooner than next Thursday, possibly the following Tuesday. Okay, so that's when the first test is coming. So I may go on and give it to you next Thursday just so you have an extra weekend to work on it. So we'll see. Any questions? All right, if there are no questions, I'm going to stop sharing. I'm sick and tired of sharing here. And if there's no final questions, I'll just say have a good weekend. But please, folks, have a safe weekend. I got a phone call yesterday from one of my full-time instructors. She had gone to campus for some reason, they're making them go to campus 2 days a week because of my health situation. I can't do that. But she has been going to campus 2 days a week. She went yesterday. They took her temperature before she entered campus. She had a fever. So they would not let her on campus, which is a good thing. So she had to leave there, go to the doctor, go get a test to see if she might have COVID. My guess, by her being on campus 2 days a week, that's probably where she picked it up because she was being very, very careful. So folks, please be careful. Labor Day weekend, I know you like to get with family and friends and things like this. Wear your mask. Keep your social distancing. Do 6 feet apart. Like I said, we're going to the lake with my parents-in-law. They've been isolated. We've been isolated. We're still going to sit at opposite ends of the table. Okay. Karen and I will sit across from each other. They'll sit at the other end. We won't quite be 6 feet apart. We're going to be as close as possible. I mean, as far as far apart as we can get and be comfortable. Okay. We're going to have a good time together, but we're going to be safe as much as we can. So please do that, folks. I don't want to lose any of you. Any questions? All right. Well, then have a good weekend. And of course, working on Trig will make it a good weekend. So take care. Go end the meeting. Bye-bye.